All right, let's continue looking at some of the questions from our test review. Here with number 7, we're starting the calculator questions. The questions where you are able to use your calculator. This one says a student is measuring water levels at a pier in California. At high tide, the water level is 13.5 feet. Low tide occurs 6.5 hours later, and the water level is 8.5 feet. Which of the following functions could be used to model the water level if x represents the number of hours elapsed since high tide? Well, the first thing I'm going to do here is kind of draw a little picture of what they just told us. Our high tide is 13.5 feet, and they said that we were counting hours from high tide, so that means this one's going to be at 0. And then my low tide is 6.5 hours later, so that's going to be at 6.5, and that value was 8.5. So that means that my graph would look something like this part of the graph that we can draw based on this information that we have. So again, I'm trying to write a trig equation, trig function, so I need to figure out A, B, C, and D. But first, remember, we're going to save C for the last. Let's do A, B, and D. A is going to be my amplitude. D is going to be my midline. Let's do those two first. So if I figure out my amplitude here, I'm going to do 13.5, the high point, minus 8.5, the low point, and I'm going to divide that value by 2. So 13.5 minus 8.5 would be 5, divided by 2 is 2.5. That is going to be our amplitude. So based on that, it looks like I can cross out B, because that one has an amplitude of 5. Next up, our D. Actually, every answer choice has a D of 11, so that's probably what D is. That's going to be where our midline is, and halfway between 13.5 and 8.5, that would be 11. That's our D. The next thing we need to figure out is our period, so that we can determine the B value for our equation. We need to know what B is. My period. So with the information that we're given, we know that from high tide to low tide is 6.5 hours, and it's going to take the same amount of time for the tide to go back up to high tide. So 6.5 is actually half of a period. That means that the full period is 13 hours. And so my B value is going to be, B is going to be equal to 2 pi divided by the period, which is 13. So B is 2 pi over 13. So with that information, looks like we can cross off D, because that's got 2 pi over 6.5. And now we're left with A and C. And the only difference in these two is one is the sine equation and one is the cosine equation. Neither of them have a horizontal shift. Neither of them have a letter a number in there being added or subtracted to the x. And so that means that we're starting at 0. If I look at my little drawing here at 0, I'm at 13.5, which is at the top of the cycle, and cosine is the one that starts at the top, and so cosine would be our answer C. All right, question number 8. What are the solutions to the equation cosine x equals negative 2/3 over the interval 0 to 360? So, whoa, let's try that again. Cosine x equals negative 2/3. We have a calculator for this question. So in order to find x, to find this angle, I need to do inverse cosine of negative 2/3 in the calculator. Now before you type that in, notice that we're looking for an answer in degrees. So you need to check the mode in your calculator, make sure that it's in the degree mode. Now when you type that in, we find out that x is equal to 131.810. And so if I think about that, I'm going to draw a quick picture of that. 131, that's going to be in quadrant 2. Maybe like right here. 131.810 degrees. So I want to find another angle that would have the same cosine, because there should be two answers to this, two solutions to this equation. My starting value for cosine was negative. I had negative 2/3. Cosine is negative in quadrants 2 and 4. I have the quadrant 2 angle. Oh, nope, not 4. Sorry. Quadrants 2 and 3 is where cosine's negative. I have the quadrant 2 angle. I need to find that same angle in quadrant 3. And in order to do that, I need to know what this reference angle is right here. So to find that reference angle, we're going to do 180 minus the 131.810. And if I do that, my reference angle I find out is 48.190. And so to find my angle in quadrant 3, I need to have the same reference angle. And so I'm going to add that to 180. 180 plus the 48.190. And that gives me my other angle, 228.190. And so based on that, it is answer choice B. Answer choice B on your review. Next up, question number 9. Consider these two equations that can be represented by graphs. Graph 1 represents the height of a basketball dribbled by a player at a controlled rate of 2 bounces per second from a height of 3 feet above the ground, starting from the height of 3 feet. Graph 2 represents the height of a basketball dribbled by a player at a controlled rate of 3 bounces per second from a height of 3 feet above the ground, starting from the height of 3. And then we want to figure out how these two graphs compare. Well, first of all, I'm going to just make a quick sketch of these two graphs. So graph number 1, we've got a basketball starting out at a height of 3, 1, 2, 3, and it says that this player bounces the ball 2 bounces per second. So I'm going to say this is 1 second, so this would be half a second in feet. My ball starts up here at 3, and if I'm going to get 2 bounces in a second, that means that I'm going to go down and back up in half a second, and then down and back up at the end of a second. So there's the ball bounces back up to the hand, down to the ground, back up to the hand. That's graph 1. Now graph 2 is going to be similar to this, but a little bit different. 1, 2, 3, starting up here at 3. This player bounces the ball 3 bounces per second. So here's 1 second. This time I'm going to divide this up into thirds. And so my ball is going to bounce once in a third of a second, and then again, there we go, 3 times in 1 second. So there's our two graphs. How do they compare? Answer A, the amplitude of graph 2 is greater than the amplitude of graph 1. Well, that is not true. Both of these graphs have the same amplitude, so that's not the answer. B, the period of graph 1 is longer than the period of graph 2. So on graph 1, the time that it takes to complete 1 cycle, the period is equal to 1/2. And on graph 2, the time to complete 1 cycle is only 1/3. And so yes, the period of graph 1 is longer. So it certainly seems like that's our answer. Let's consider the other two. Graph 2 is a vertical translation of graph 1 by 1 unit. Well, that's not true because they're both going up and down between 3 and the x-axis. There's no vertical translation. And then D, graph 1 and 2 both have a phase shift of 3 units. Phase shift meaning a horizontal shift of 3 units. And they don't, because they both start with a high point there on the y-axis. And so our answer is answer choice B.